program for Science 3rd Prep Stage. Today we have an important session about revision. About what? About our lessons in whole term. Concentrate with me very well in many types of these questions and all parts of the revision today. Let's go to see our revision and concentrate with me very well. Let's go. Now we have the first part of our revision today, how reactive are alkali metals with water. How can these alkali metals that react with water? What are the equations? What are the reactions that happen between what? Between these metals and water. So here we have what? We have the substance bank and we have some amount of water. This is about what? About the chemical reaction, the first part. And we have simple substitution part. So here we have what? If I have this start and I get by these four steps, we have what? We have sodium. What will happen here? If I get the piece of sodium and put it inside some amount of water like this, what will happen here? Here we have what? We have this amount of water like this, and the sodium it's float on the surface of water and get some hydrogen outside. Why? Because sodium or any type of these metals that substitute the hydrogen from water and makes what? And makes some alkali solution inside the water after the completing reaction. Again we have what? We have another one like this. We have what? We have potassium here, and the potassium that put it inside what? Inside water like the sodium. We have some amount of heat energy, and we have here what? We have some pop sound and what? And fire. That's what? That produced by this reaction, because the potassium and sodium, they are very active metals. Why? We have what? We have these metals that substitute hydrogen in water here. Another one, to make what? To make this reaction, we have rubidium, for example. It is like sodium and potassium that makes what? That makes explosion like this. And we have some smokes that produced by this reaction. This is what? This is a type of substitution or the type of gas that's called hydrogen gas. Again, in last time we have what? We have here the sodium one, or piece of sodium. That's what? That's used like this. It's float on the surface of water. Why? Because its density, it's what? It's less than the density of water. So it makes reaction and make the motion like this on the float on the surface of water, because it's what? It is very active element. Potassium, the other one, we have potassium that makes what? That make this reaction like sodium. It has the fire. This fire that produced by hydrogen gas with pop sound, to make what? To make substitution between this strong metal and hydrogen. And we have a question here. If I have any one of these metals here and make substitution with what? With hydrogen in water. Why? Because here we have this metal, they are a strong one, and what? And the hydrogen is weak element. Why? Because they are arranged in the CAS. What's meant by CAS? We have chemical activity series like this. So here this reaction, it's happened by what? By the sodium or potassium or lithium or rubidium or cesium, anything of this. Because what? Because these metals, they are very active, very strong one. So these strong metals that react quickly or immediately with water here and substitute the hydrogen from it. Another one for fun, we have what? We have another metal like that called cesium. Cesium here, it is very strong one, stronger than sodium and potassium. So here we have this sodium and potassium or cesium. Cesium, it makes explosion and damage this beaker like this. If I put it like this, so we have what? We have damaging of this part of what? Of the glass. Because what? Because it is very, very active one. Now we have another part to revise. We have the thermal decomposition of copper carbonate. What's meant by copper carbonate? Copper carbonate, it's what? It is a type of compound that contains copper and carbonate group. and we have here lime water, and we have the flame. This flame help us to make the thermal decomposition of what? Of this compound. To what? To make the result or products of this one. Thermal decomposition, it is a chemical reaction. Concentrate with me very well to make the definition, to study this definition of each part of these types of chemical reaction. We have thermal decomposition. It's a chemical reaction in which heat break a compound down. Heat the compound and break the compound down. Why? Because it means what? It means it's broken. It's this compound by heat energy is broken into what? Into simple compounds or into simple elements. So here into what? Into two or more products. Products here, maybe two compounds, maybe compound and element, maybe two compounds. Let's go to see the first thing we have. We have the heat energy like this. We have the flame, and here we have the conical flask that contains what? Contains copper carbonate. As the copper carbonate is heated, the gas formed which travel to the lime water and turns to it cloudy. This is the experiment here. If I have some amount of copper carbonate here and I heat them like this, the gas or a gas that produced and move here in this what? In this type of tube. This is U-shaped tube or connected tube. To reach what? To reach here we have lime water. This is what? This is clear lime water. The copper carbonate changes color from green to what? To black. Why? This is a give reason. We have a question. We have give reason. This give reason is copper carbonate changes color from green to black, or in another words, we have the copper carbonate color disappear. Why? Because if I make the heat energy during time like this, we have some gases that produced here. These gases changed lime water into milky color here, concentrate here very well. And here we have what? We have here, this is the lime water that's what? That change into milky color. Why? Because the carbon dioxide is produced here. After that, we have the thermal decomposition of a copper carbonate. What is the gaseous product is in this reaction? Which one? Hydrogen gas or carbon dioxide gas or oxygen gas or sulfur dioxide gas? Which one? We have here the key word. We have carbonate. Which one that's similar to this word? We have what? Hydrogen? No, it is not from these letters. So here we have carbon dioxide. Maybe we have carbon and carbon. Concentrate with me very well here. We have oxygen. It's maybe, but we have no oxygen that produced and doesn't make any change of the lime water. Which one that change lime water here? Copper, carbon dioxide, sulfur dioxide, oxygen or hydrogen? This one, it's carbon dioxide. Excellent. So here we have what? We have the carbon dioxide. It's the gas that produced this reaction and it changed the lime water into milky color. After that, we have here the black solid product of the reaction is called copper oxide. Write the word equation for this reaction. We have here carbon dioxide, we have copper oxide, we have copper carbonate. Which one I put it here and which one in the second one and which one of this compound in the third square? Which one? Number one, we have copper carbonate. It must be put here. This is the reactants. So the reactants here, they are what? They are the copper carbonate, just copper carbonate to make this reaction. Why? Because I use heat energy to divide or to break this compound into many compounds. Number two, we have copper oxide, and the second one in the product we have carbon dioxide. So here we have what? We have copper carbonate that give us by heat energy. We have copper oxide and we have carbon dioxide. If you substitute the copper oxide and carbon dioxide with each other, there's no problem. Why? Because they are the products, two of them or both of them that produced by this reaction. So here we have what? We have the carbon dioxide and we have copper oxide here. So here we have another thing. We have the formula of copper carbonate. It's very important to know the compound formula. thermal decomposition of the copper carbonate, we have formula here of this one. The copper carbonate is CuCO3, and we have the formula of calcium oxide is CuO, and it has black color. So here we have the copper carbonate, it has green color, change it by heat energy into copper oxide, is black color. Use these symbols equation for what? For make reaction. And here we have the symbol equation, we have the symbols of all products and reactants. Which one? The first one. Here we have the copper carbonate, like the word equation. And we have the second one, we have copper oxide, this is right. And we have the carbon dioxide. They are what? They are the, or represent the equation here, or symbolic equation, the equation of this reaction. Copper carbonate, that by heat energy change it into, or decayed or decomposed into, copper oxide in black color, and the carbon dioxide that change lime water into milky color. After that, we have here which one that's solid, which one liquid, which one gas. And here we have what are the correct state symbols, okay, of each product. That's what that produced, which gas that produced, which solid that produced. Why? Because here we have some kind of what? Of the compounds that produced, and we ask it about what? About the state of each one of them. So here we have, for example, if I have complete the gas that produced from the thermal decomposition of copper sulfate is space. Which gas? We must know the types of gases here that produced by each type of this reaction. So here we have copper carbonate. We see before in this experiment we have it's what? It is solid one, right? Why? Because S, it's symboled by solid. So the second one we have copper oxide. Copper oxide is what? It's solid also. Why? Because it's powder. So the powder here, it's solid state. But the carbon dioxide is very easy. It's liquid, mister. No, it's wrong. Why? Because here we have what? We have carbon dioxide gas. It's what? It's the gas here. So here we have what? We have copper carbonate is solid. Copper oxide is solid. Carbon dioxide is gaseous state. Another thing here, we have which metal will react most with acid. What's meant by acid? Yes, I hear you. The acid, it's what? It is a compound that produces the hydrogen ion, excellent, in its solution. So here we have, when the metal is added to an acid, what will happen? Here we have some acid that added to each one of these metals. Here we have a question first. Here we have the first one, copper. The second one we have zinc. Third one we have magnesium. Cu is copper. Zinc is Zn. And we have Mg, it's symbol of what? Symbol of magnesium. Which one that found before hydrogen? Yes, very good students. We have what? We have magnesium and we have zinc. They are what? They are found in the chemical activity series in what? Before hydrogen. So here we have the copper is found after hydrogen. Excellent. So which one is the least one in the chemical activity, and which one is the most active one, and which one is active? So here we have, let's go to see. Here we have the when the metal is added to an acid, a salt and the hydrogen gas is formed. Some metals are more reactive than the other. It's rule. It's the rule of this experiment here. So we have what? We have here, take the play, and the stage number 1. If I get some amount of acid here, HCl, and put some amount of this acid on what? On the copper. Copper here, it's a metal that has golden color, and I make like this. Why? Because here we have the reaction here and some amount of gas that reach the second tube. So here if I have any one of this reaction, we have bubbles, the gas that appears in this reaction as bubbles. Here we have a bubbles? No. here we have any reaction that happened? No. Why? Because this reaction that doesn't happen. So here we have the hydrochloric acid HCl is added to the test tube containing a piece of copper. How reactive do you think the copper will be? What happened? Here we have any bubbles that appears? No. Here we have any gas that produced? No. Here we have any reaction that happened? No. So here we have what? We have there is no bubbling on the metal and no gas that collected in the boiling tube or the other tube like this. This the second tube that collect any gas that produced if I have any reaction. So here we have, this means that the copper has not reacted with the acid. Why? Because here copper, it's found what? After the hydrogen gas in the chemical activity series. So the chemical activity series, the arrangement of some metals and the hydrogen according to the chemical activity from the most active one to the least active one. So here we have what? We have the means, that means the copper doesn't make any reaction. Second thing, I have the second one, we have zinc. Zinc, it's what? It's another one. So here we have bubbles that appears. Master, we have here a reaction, right? So the reaction that happened here. Why? Because some gas that found, or the reaction that happened here between zinc and what? And the HCl. So if I have HCl that added, it is not important 5 centimeter or 10 centimeter, any amount, but it is little amount, please. So here we have HCl is added to the piece of zinc, and the bubbles on the zinc show that it reacts with the acid. So the gas is produced and collected in the boiling tube. And what will happen? We have a gas that move from here to the other tube, from the tube of reaction to the other tube. So this reaction that happened here with the acid, so here we have what? We have hydrogen gas that produced or that collected in this what? In this tube. Another one, the gas collected from the reaction. I have the matchstick like this and I put it like this. So we have what? We have the shape here that makes what? That makes pop sound. Again, we have this one. Here we have the gas that found here, and we have matchstick. If I near this matchstick inside what? Inside the tube that contains the gas, it makes pop sound. And this pop sound, it's what? It's the hydrogen gas. So the gas is collected from the reaction between HCl and zinc. It tested with what? With lighted splint. Lighted splint, it means what? It means matchstick that has fire. So this fire, it has pop, or it makes pop sound. With what? With hydrogen gas. After that, we have magnesium, the last one. And if I put some amount of magnesium, we have a strong reaction here. So here the HCl is added to the piece of magnesium. The magnesium react vigorously. Vigorously, it means what? It means producing lots of bubbles of gas. And this gas, and how could this test it? We have what? We have this test. It makes what? It makes this test like what? Like the first one or the last one we have. So here we have the hydrogen gas that produced here. We have the pop sound here. After that, we have another type of chemical reaction that called double substitution reaction. So here we have two compounds. We have sulfuric acid. We have copper oxide. So here we have the copper oxide and sulfuric acid. What will happen here? When the copper oxide that added to an acid, it dissolved inside it and reacts. It makes reaction. How come? Let's go to see. The first part or first thing that we have the flask contains some amount of copper oxide, and I put it by the spoon in the what? In this acid that called sulfuric acid, H2SO4. When the copper oxide powdered is added to the sulfuric acid, it dissolves, causing the solution to go to blue. So the change of the color between the two compounds or reaction between two compounds, it makes it changing in the color of the two types of compound. Copper oxide is black and the sulfuric acid is colorless. So if I add some amount of copper oxide here on the H2SO4 sulfuric acid, change into blue. So here we have what we have. The solution cannot dissolve anymore. So here we have what we have, some amount of copper oxide that dissolve inside. So we have no dissolving here because we have what? We have some amount of copper oxide doesn't dissolve. Why? Because the solution here, it is a revision about the solution here. Solution, it's what? It is super saturated solution. Excellent. Why? Because here we have some amount of what? Some amount of the solute that doesn't dissolve in the solvent. Why? Because it's what? Saturated with what? With the solute. So here we have the eventually we have the solution cannot dissolve anymore powder because what? Because the reaction is complete. We have the excess copper oxide, that's what? That's separated by what? By filter paper to make what? To make the compound that produced here. This compound is what? It's copper sulfate. Why? Because here we have copper oxide with what? With sulfuric acid. So it is copper sulfate that produced here. And this is the amount of copper oxide that doesn't dissolve in water. So here we have the supersaturated solution can what? Can separate it by a filter paper. After that, if you heat this compound or this solution by what? By the flame. So the water vapor that move out like this, and we have the new compound that produced like this. This compound, it's called copper sulfate CuSO4, and we have some amount of water that's what? That move away or that evaporate by heat energy of this reaction. So here the filtrate that contains the copper sulfate or salt formed by what? Formed by reaction between the sulfuric acid and the copper oxide. So this salt is separated from the solution by what? By evaporation. Why? Because it is what? It is a solution here. It's very easy to know this information here, but must be studied very, very well. We have an acid. We have a calcium carbonate compound. So this calcium carbonate, it is a type of chemical compound. And we have what's happened of the lime water when the calcium carbonate is added to the acid. What will happen here? Here we have the calcium carbonate. Calcium carbonate, it is a type of compound that reacts with acid, any carbonate, or that makes a reaction between it and the acid. So it makes what? It makes a gas that move here in this tube, U-shaped tube like this, to reach what? To reach the lime water. If you see the lime water in your question, so we have carbon dioxide. It's a rule. Let's go to see. Here we have an acid plus calcium carbonate. Here we have some bubbles, and this bubble that move here, we have carbon dioxide that show downward or flow downward, and we have lime water change it into milky color like this. Lime water, it's what? It is in its color, it's like the water. It's colorless. It's clear lime water. But here, if I have some amount of this calcium carbonate with some amount of acid and they react with each other, any type of acid, sulfuric acid, nitric acid, hydrochloric acid, any type of this acid, phosphoric acid, any type. So here the acid and the calcium carbonate, this is what? This is the carbon dioxide, that's what? That's flow downward here, and the lime water changed milky like this, milky color. So here the lime water again, in last time we have lime water used to detect the presence of what? Of carbon dioxide gas. Another one, we have how will these metals react with acids. Again we have the metals and the acid again. Which one is active, which one is not active. So if I here we have what? We have Na. What the symbol? This one represent what? Sodium. And here we have Mg, magnesium. Fe, we have iron. Pp, it is a lead. And we have the last one, we have Cu, it's copper. Here we have the first one. First one is sodium here. Sodium, if I put the sodium inside the acid here, we have some amount of what? Of the heat energy that produced and makes what? And makes reaction like this. Here we have the fire and the float on the surface of water. So here we have Na is very strong metal to substitute the hydrogen from its compound. This compound is acid. Which acid? Any type of acid. The second one, we have magnesium. Magnesium, it's what? It is more dense than the acid, and it makes some bubbles like this. So the reaction here and here, it's big difference between them. Why? Because sodium is very strong and magnesium is less active than this one. So it is clear to us to make what? To make reaction with sodium, between sodium and acid here, it makes what? It makes fire on the surface of water here. And after that we have the iron. Iron, it is less active than the magnesium and sodium, so it makes very weak reaction, very weak or very little amount of bubbles after a period of time. It takes long time, longer than magnesium and sodium. Sodium is immediately. Why? Because sodium is found before hydrogen in the chemical activity series, and the magnesium is found before hydrogen in chemical activity series. So it is what? It's very easy to substitute the hydrogen from its compound. And we have another one, we have lead. Lead, it makes very small reaction. It is very weak reaction. Why? Because it's not found, or it is found before hydrogen in this chemical activity series, but it is what? It is very least one of this chemical activity. But the copper, it doesn't make any reaction. Why? Because copper here, Cu, it makes what? It makes some amount of reaction? No, it doesn't make any change in the acid. Why? Because copper is found after hydrogen in the chemical activity series. It's very important to know the chemical activity series here. Why? Because Na add magnesium, iron, lead, copper, gold, silver, any one of these elements must be know the position of each one of these elements before hydrogen or after hydrogen. If this one is before hydrogen, so it is active one and substitute the hydrogen from its compound. But if I have one element or one metal like copper,